In this extra special episode of The Full Nerd, Tom Peterson and Ryan Shrout of Intel talk ARC. Welcome to an extra special episode of The Full Nerd. I'm your host, Gordon Mong, with co-host Brad Charkis.
Hello, Internet. The
famous Tom Peterson of Intel.
Hello, Internet.
And also the equally famous Ryan Shrout of Intel.
Hello. Hello.
And of course, Adam Patrick Murray is controlling you vertical and horizontal.
It's true. We're having some technical difficulties with YouTube, so we're not alive over there right now. But hopefully, we will get that back soon. So we're on Twitch. It's exclusively on Twitch. All of you cool Twitch chats.
It's our new exclusive content.
I know. Yeah, exclusive. Cool. But we're here to talk about. What are we here to talk about? Battle Mage? No.
We're here to talk about ARC. In fact, in front of you on the camera, you can see an A750 in real life.
Very nice.
It's being held on a cool video card holder, which another company provided for us.
Can anybody guess what that is?
I don't know. Actually, that would be cool. I decided not to offend the other company and cover it up, but I thought it was cool. If you can, it's like that's our hidden gem. That's just a little thing there.
I can actually see it from the back, so I know what it is.
Oh,
I know what it is too.
And of course, we also have a box for an ARC A770 here. The A770, in fact, is not in the box. It is powering a box behind us with an i9 12900K running Windows 11 and Borderlands 3.
Yep.
I visually confirmed it to make sure. In fact, I installed.
Wait, watch this. I can do this.
Are you
going to go back there and play?
Oh no!
You're going to go play?
What are we doing?
I installed Windows 11
clean
clean this morning on an SK Hynix drive, Gen 4.
Oh, it's inverted. Oh,
yeah, and that is a horrible secret, people.
Oh no! We're gonna.
Ryan Shrout has been trying to hide this forever. He's an inverted mouse.
25 by 14s, high settings. Amazing.
Yeah, but you skipped over the thing about where he was giving me crap for having an inverted mouse in game.
It's weird.
Yeah,
it's weird.
See, I always take that back to the first games I played on a PC were flight simulators. Right, and so that's just what I became accustomed to.
Oh wow!
But I've come to realize I'm literally the only person I know that does inverted. Brad, do you do?
I don't use inverted mouse, but I also grew up on flight simulators with the HOTAS sticks. So whenever I play with a controller, I have to do inverted controller, and it always screws up every CES demo, every E3 demo I ever go to.
I noticed the weird oddity. I was telling you I was playing Stray, right? The cat game.
Great game.
Right?
Great game.
Oh my God.
And what I noticed is I did inverted controls in that, but in the there's like frozen, like cut scenes, like interludes, right, where you're not actively controlling the cat.
Cat's licking itself.
But in those moments, the inversion does not apply. And it's like the game is like not. It was odd. Plus, there's adorable sections where the cat puts a bag on its head, and all the controls are like randomized and stuff like that.
Because you're kind of trying to get out of the bag.
Yeah.
I got to be honest. That's the first time I played on an Intel discrete GPU, and now I'm always going to have it associated with horrible controls.
Damn, that's some bullshit right there.
But you can confirm they're not going to. It's not going to ship that way.
With inverted controls, no.
I had to change the setting in
beta.
Borderlands 3. Yes.
Okay, there we go.
But I mean, obviously, the big news is it's running at 90-ish frames a second. Yep, 1440p high. And you were saying, because we have a 3060, we'll drop that in later, but in general, it's going to perform better than a 3060 in Borderlands 3.
Depends on your game, right? And it's a little bit complicated because we have some titles that I'll call like perfect. Like they take advantage of our architecture, our Xe cores run well, it runs fully pipelined. You get the performance that we want you to see, right? And that's when the title is sort of like well matched to our particular microarchitecture. That's more modern titles like DX12 versions of older games or DX12 titles. And then there's sort of like the next level of titles, which are using modern APIs, but maybe don't work perfectly, but they're still pretty good. So that's like almost all DX12 titles and all Vulkan titles are going to do pretty good. And then we have what I'll call DX11, DX9, older titles, older APIs, and we're just going to be working on making those better basically forever. It's sort of like the infinite tail of titles that everybody's going to be playing. We have a lot of catching up to do in terms of we haven't done 20 years of development running DX11 or DX9 or DX7 or whatever games, so we have to work through those. I think that's a pretty fair thing.
It's fair. It's for your specific question about this, right? 25 by 14 at high. This is one of those games that works very well on Intel Arc. And so, comparing it to competition, we had a graph out on this and it had a Borderlands 3 data point in it. And I 10% or something faster than a 3060 product.
Yeah, than 3060. Now, I would say in general, at this class, we're going to win convincingly versus a 3060 when games are well optimized on Arc.
Yeah, that's because you guys are going to be, you said on the Linus Tech Tips, basing price around the tier 3 games, right?
Yeah, Linus came up with that tiering nomenclature. We don't really use that tiering thing, but he does. And
well, he convinced you to say it in that pseudo ad read that you did as well.
So I just do what I'm told, man. I just do what I'm told. Linus wrote that script. So anyway, the fact is that we do have these multiple kind of bands of performance buckets, and we are fundamentally basing our value proposition, our pricing around the total delivered solution, including all of those DX11, DX9 titles. So the way to think about it is if you're running a newer title and you like that DX12 DX Vulkan implementation, you're going to get a heck of a value, because the truth is the pricing model that we're using is much more based on the overall experience that we're delivering.
And it's worth noting, right? The Borderlands 3 is a good example of a title that has both a DX11 and a DX12 option there.
Yep.
And it's one of the things that we call like education, but it's like, hey, turn that on.
Run the DX12
on
version.
Intel Arc graphics cards, right?
Yeah.
If it has that option to do it, and it's cool to see, Fortnite implemented a DX12 option, and World of Warcraft implemented a DX12 options. Like, so a lot of very popular older titles are still.
And I think it's just a natural thing. I mean, the API itself is not that hard to implement if you already got a DX11 version. So it's just kind of one of those things that we expect over time, and that's kind of where we're investing first, is make sure the modern titles with modern APIs run well, and over time we're just going to keep on making a little bit better day by day.
Do you get any kind of bump from the years and years of Intel integrated graphics support? I mean, because I kind of figure some of that base must help.
Oh yeah, it does. And what's truth is that it does help in the sense that we've got a long history of the driver, but it's a really different optimization. And the optimization, you might have said, well, maybe we're a little bit more CPU limited in lower end graphics. So you might have spent all of your time on a particular optimization path. And now it's with a higher performance engine, it's completely different optimizations that's required. So our balance is dramatically different between CPU and GPU power. And that's really where the work is starting to come up, where we really need to start thinking a little bit better about how we're managing memory. And even the memory model is very different. Like, we're talking about 8 gigabytes of dedicated memory. That's all learning for our GPU driver team about how best to manage that.
Do you, as far as how valuable is, I mean, it's funny because it feels like you're pricing it based on older API games.
Yep.
What does that matter? If you sort of have this class of card, isn't everything, I mean,
isn't everything new?
I mean, like Stray, I don't imagine it's going to be like, oh my God, we're just chugging here on Stray.
No, it's going to look great on Stray.
So then why does that,
why would we even consider the old games?
Yeah.
Well, we're a new entrant. Right, and there's a million old games that people want to play, and we want to deliver a great value for those guys, because the truth is we have to say, hey, we're Intel and we're entering the discrete graphics market, so here is our kind of like our entry position, and it's going to be great, and you're going to get leading perf per dollar for new titles, and you're going to get a fair deal for older titles that we think are going to get better over time, and they're going to approach what we can deliver on these new titles. By the way, that's another thing I want to mention, Gordon, is that we are a new entrant, and so we've done some crazy things with our Intel cards that we should maybe talk about, that are just sort of like these little extra perks, like that RGB stuff back there, right, and extra memory on that card. It just says, hey, we're here, and we're trying some new stuff, and it's going to be fun. And I think I hope gamers are going to appreciate it.
Yeah, and we'll try to show a close up of it later, but but the card has, if you can see, it has this cool RGB ring around it.
Yeah.
And it is RGB, and also it's got a very diffuse glow around the fans. And again, you could go check out videos already on Linus Tech Test, but he was really impressed. I dig, I'm an RGB person, so I really
do you have RGB on your like little cell phone earbud thing?
I wish I did.
How about your sneakers?
I would actually have it if they sold them in my size. I have white.
I can confirm.
I may have actually just bought golden sneakers with the RGB lights in the base off of Amazon.
Wow,
there you go.
Wow.
I own a pair as well. I blame my daughter's cheerleading competitions, and so the dads all bought like matching light up shoes, and they had to be RGB to match the color of whatever they were doing that day. Yeah.
But I just have garish taste.
You really, it sounds like
no excuses. No excuses.
But it sounds like you're really sort of like approaching this with very realistic goals and humility, which I think is, refreshing, and then also kind of good, because I think, when people see the CPU side, Intel has dominated CPUs decades and decades and decades. You're a new entrant here, so it just sounds like I think a lot of people kind of thought, are you just going to come out and say, hey,
here it is.
Here it is. I mean, I don't want to bring up old wounds, but i740, right? It really people.
Wow, really old wounds.
Really old
Jesus.
wounds. At that time, because I remember, because I was actually covering it in the industry, but it was like really, the expectation was
good news
from analysts,
yes,
and honestly, a lot of press. The few of us that there were that covered this, but like Intel getting into this is like they're gonna dominate. It's gonna be an end of all these like dozens of little small folks.
Yep.
And it feels like the approach this time is very different.
You're absolutely right. And if I'm not mistaken, was that designed in Phoenix?
I don't know.
Florida, I think, right?
Florida?
Real 3D.
I'm not sure. Yeah. But I remember
it turned into the integrated graphics on the chipset.
It did. Yeah. So that IP got sucked in, and it became like Gen 1, Gen 2. Now we're on Gen 12?
Yeah.
Gen 12. Wow. Back to your question, though. I think I view this as we understand how entrenched the current competitors are, and how, it's almost like 20 years advantage. We've been sort of watching from the sidelines as graphics have become more and more critical and more important, not just to gamers, but also business and compute and servers and everything. So for Intel, I believe this is kind of like an existential operation. It's not like we're going to see if we can do well for gamers. Gamers are hugely important, obviously, but we also care about servers. We care about data centers. We care about, efficient vector compute, matrix compute, which is accelerating most of the important algorithms in the future. So my point is that this is bigger than graphics for gamers. It's graphics at Intel is a hugely important endeavor.
This time, because I mean, let's talk about the elephant in the room. The launch in China did not exactly come over great. I think a lot of people thought a lot of people were like, oh my god, this is like it. It's like suddenly 6500 XT is like, oh yeah, you made fun of me, huh?
Oh yeah. We learned a lot. Now I'm not saying the strategy was bad. It was not a bad. I mean, in hindsight, it was a bad strategy. What did you say?
Well, I mean, there were reasons for that we started where we started and how we started. Right? One of them was when we were starting to ramp all this. Right, we were in this March through May area where everything was locked down in China again, and we couldn't get components out, and it was easier to build and source locally, and you could distribute. We could a much faster time to market to go do it. Right. And it made sense, especially because that part of the world has more of an appetite for that class of a GPU product, and it made some sense then too. But I think our fallacy was assuming that we'll just launch this in that market and it won't filter out into the rest of the world.
You're absolutely right. We didn't do what I would say in hindsight we should have done, which is we should have realized that launching it in China is effectively launching it worldwide. And so we need to have a press strategy. We need to do samples worldwide. We need to do engagement and then work through all the issues, because when you launch a new GPU, there's going to be stuff that goes on. In this case, I would say another big thing that we didn't do, since we weren't engaged with these global press, like some guys in Germany, some guys here in the US, they didn't know about this whole rebar thing. right? And so I've been out talking about people. We have a unique graphics memory controller that has some unusual like behaviors. It's designed for working with more modern platforms, and there's a feature in almost every BIOS that's called resizable bar. I think what did AMD call it? Like
smart memory access,
and NVIDIA, I think they call it just
smart
resizable bar. Yeah, but you got to turn it on for ARC because our memory controller is designed to work with that active. And if you don't have that active, you're going to get significantly lower performance. And that's what happened all around the world. Uncontrolled, people didn't get the message. So we learned a lot, and that's part of the reason that Ryan and I are out in the world, and we're just trying to say, hey guys, we're not totally out of control.
Can you speak any further to why rebar makes such a big difference?
Sure. So first of all, what is it? Let's just start with the basics. So rebar is a PCI Express feature, resizable bar. And what it does is it says the CPU, when it initiates a transaction, whether it's a read or a write, normally is limited to how big a transaction that can be. In some cases, it's like 256 megabytes. In some cases, it might be smaller. And that's true for reads and writes. So when you turn on resizable bar, you allow a single transaction to do a chunk of data. And that's good for things that are like large, like for example, textures or maybe a shader program or geometry chunks. Now on our memory controller, it is designed to work well with large transactions, right? Parallelize the data moving out, parallelize the data read coming back. And it kind of gets a little, chunked up when you do a lot of small transactions. So the truth is, if you do turn on rebar, we get these big transactions. The memory controller works as designed. Everybody's happy. You turn off rebar, we get a lot of little transactions from the CPU during things like texture loads or geometry loads. And it makes those spikes that occur on frame time worse, because those spikes are already happening because there's usually something like a texture load or a geometry load or something moving from the CPU to the GPU because there's a scene change or an effect is changing. So at the end of the day, it's a combination of the memory controller being sort of more sensitive to lots of little transactions. And that's why we need to get out there and communicate, hey, turn on rebar.
I kind of wonder if a lot of people didn't even bother to check because, most people
I think it's
NVIDIA,
fair. Yeah. Right.
Yeah.
It hasn't made any difference.
Yeah. It actually, it does. It's like 5%, 10%, depending on the games. It's not huge, right?
Yeah. It's hard to find though.
Yeah. But I totally agree with you. We are much more sensitive. Yeah.
I'm not sure if you guys would know the answer to this, but is enabling PCIe rebar now the default for Intel Core chip platforms?
I think that's option controlled by the motherboard ODMs. So if you look at it, they're usually configuring their BIOSes differently. Some call them different things. Yeah. So I don't think Intel controls that default as far as I know.
Okay. But it's good for us to check on that.
Yeah, we
right?
definitely.
What's the default behavior? And
as far
making sure consumers are aware of it.
Yeah, as far as I can tell, there's no downside to turning it on, and I think it's more like just how these things work. It takes forever to get the understanding out there that this should just be defaulted to on.
Yeah, will it work on both AMD and Intel platforms? I know that was one of the concerns in some of those German reviews.
Absolutely, there's the concern from the Germans. The German reviews really came from positioning that we were doing at the beginning of this, trying to kind of say, let's control the platforms to a few that we can basically say, this platform, known good, just run this platform, turn on resizable bar. And we didn't want to like make it more complicated and induce more system, craziness. Well, the truth is, again, that was a little naive thinking that we could control that. So now we're being very clear. Yes, we work with all platforms. We work with all CPUs, all vendors. It's just like any other graphics card.
Yeah, I have a couple follow-up questions from the chat. My first one is, so people like us, we might understand how to do that, but I know some people that I've helped build PCs, they don't know what rebar is. They don't know. They don't even know what going into the BIOS is going to look like. Yeah. How would you help to kind of inform everybody else?
So we actually have a pseudo solution for this that we're working on. Right, we have a support document and a tool that you can download. That if you have an ARC card installed in your system, it will tell you if you have resizable bar enabled or disabled. Right now, and then it has some generalized directions of, hey, if it's disabled, go into the BIOS, look for things that sound like this. But every motherboard's a little bit different, every menu system's a little bit different, so it's hard to do it individualized. But it is something that we have some messaging and a tool built around.
It's a hard situation. It's not we're not delighted to be in this spot, but really working with folks like you, right? Over communicate, education, yes. Reaching out. Every time I'm in front of a camera, I'm not talking about random stuff. I'm saying, if you buy this graphics card, turn on Rebar. So yeah, see if it matters.
So another question, and I tell you what, I got a lot of questions from Dr. Ian Cutress of Tech Potato fame.
Hey,
Ian is here in Twitch chat.
Crowd Ian in here too somewhere.
I know.
Get him in here.
I have a lot of questions from him. But
Kill two birds with one stone.
There's a limit to questions we take from
Ian. He's an analyst now.
Yeah, he is.
Ian the analyst.
But his first question that's pertinent to this is isn't a large transaction-focused memory controller more aimed at the enterprise workflow, i.e., are you sharing the memory controller between the Arctic Sound and PVC?
Ooh, well, you're absolutely right, Ian, and I'm not sure the answer to that. I suspect it's shared given the design history of those two chips, but I don't know for sure that it's shared. I would also say that it's probably not, in my mind, it's not intentional. Like this feature of Rebar needing to be turned on because of the man retrieve. I don't think we really thought through it that deeply at the design time. This was obviously a while ago, so I think it was learning, and obviously we would probably do things differently again if we had it to do over. That's my take on it. What do you?
I think that's right. It is to be clear, Arctic Sound and Arc share the same GPU, so that will be the same. But the question about is it the same memory controller in PVC? I don't know the answer to that either.
Although I imagine it would be because
PVC probably not actually.
Oh, really?
So, yeah, if you look at PVC,
different.
Has a very different lineage. It kind of comes from a very different design place, and I would argue that it's probably much more of a different memory technology, probably a different memory controller.
I just kind of think because for Intel, data center sort of butters the bread for most of them.
Oh yeah, yeah. I mean, I'm sure it's a great memory controller.
Yeah. I did want to ask because for Rebar being off, it's typically off is what I've noticed.
Yeah.
Most of the builds I've done,
they're off.
Even it's off by default. I don't know how. I'm sure the vendors just don't. They just leave it off because who cares?
Yeah.
Because again, I don't know if it really makes that much of a difference. So
I
guess that's Intel. Yeah, it does now. So
I'm hoping we'll get that default changed.
There you go.
Now, for the cards themselves, can we talk a little bit about the cards?
Sure.
Because, so we have A750, we have A770. You can see this really beautiful one here. It's running it back there. These are basically sort of your reference designs?
They are.
Okay.
Well, not reference designs. So these are production cards.
Okay.
So what's maybe also different, some of our other competitors do this, where they'll design a card and they'll manufacture it, or they'll have it manufactured under their control, and then they'll actually distribute it and sell it into the channel. We're doing exactly the same thing with this A750 and A770. So these cards are not reference designs, they're retail samples.
Okay.
And you'll see these distributed through all the major retailers worldwide at launch.
And so we've talked about limited edition. We've seen limited edition come up when we talk about the names. Limited edition is the Intel version of these products.
Okay.
Right. So we have the Intel Arc A750 limited edition sitting in front of us. We have the A770 limited edition and the system behind us, right? And those will be the two Intel branded products that come out.
Okay.
So does limited edition give a glimpse into how many of those might be available? Like if you're really Jones and want to get your hands on Intel's own graphics card,
buy it as soon as you see it.
Okay.
No.
It's going to be around. It's not like it's going to go away anytime soon, but I do think that demand is going to exceed supply.
Okay, because I mean, it's not like you're just going to only make one of 500 kind of thing.
No, we're going to make a bunch.
It's going to be about as limited edition as a limited edition Toyota Camry is the way I don't know
how many millions is that?
Yeah, no, I mean it's like you pay more for it. It's a limited edition Camry, but you're going to be able to get this.
I got to tell you, so it's a good segue. Can I maybe show a stack up chart?
Oh yeah.
Let's show this right
here. Can we switch over?
Switch over.
Yeah, let me come here. I'm going to show you this chart, right? So we've got our brands, and just to make sure everybody's clear, our numbering is very simple. It's got the first digit is a letter like A, B, or C. In this case, the A stands for Alchemist, which is our first GPU architecture that we're doing. And then the second letter is our stack. So it's like 3, if you say an Arc 3XX, that's our entry level, 5XX is mid-range, and then 7XX is our high end. So then the last 2 digits are going to be within those segments. So 770, 750, 380 are examples of product names with the full thing. So in the 770, we have a reference design or a base level that is an 8 gigabyte SKU. But you know how AICs do all that differentiation on top of what the reference SKUs are? We decided to do one of those. So our Intel card, the limited edition, actually is 16 gigabytes, and it's got all the RGB stuff, and it's going to be priced at e-tail slightly above our reference pricing.
Is there any advantage having 16 gigs of RAM?
Well, certain games. I mean,
okay.
small, but I would say think of it more like there are creator applications. There's some compute people. It's sort of like, you know, we want to give a little extra gift to the initial adopters of Arc, and this is one of the levers that we have. We can make memory a little faster, make it a little bigger. We can add RGB, and we put a cool ID on it.
Okay.
Yeah, and you like the RGB, right?
Yeah.
And will third-party board makers be able to get 16 gigabyte models, or is that going to be you guys
expect that to be rare, right? We would recommend most people build the 8 gigabyte model for the reasons we just talked about, where the 16 gig is a little bit harder to justify. But for us, we're just saying, hey, let's have a little bit of a party here. But most of the AICs I expect are going to be entering with 8 gigabyte versions.
Especially at that price. We don't know the price yet, but we'll talk about that later. But I'm just kind of like thinking A750.
What would you be willing to pay today?
I'm just.
Today,
do we have the price?
No, I don't know if I shouldn't even have mentioned this. I take it back. I take it back.
I'm kind of wondering, because you do make a good point. 16 gigs for content creation is pretty handy.
Yeah.
I just kind of thought maybe that was sort of a cynical play, because most gamers will go like, "Oh, more memory. I need."
We're being pretty transparent.
I need 24 gigs in my
more numbers equals
Ti.
better.
More's better. No, I try to be very transparent. I don't want anybody to be surprised. I think 16 gig has limited benefits in gaming, but it is something that there is some class of users that are going to enjoy it for content creation. Maybe somebody wants to run some deep learning kernels; they'll definitely love it. And I see it as it's basically a nice little perk that we can do at launch.
Okay. Can I ask about these? I want to ask about the power for these.
Okay.
Because the A750. Actually, should we go over some other?
We don't have to. No, whatever you want to do.
So, like for me, because the cards have a 6+8, so 6-pin plus 8-pin on A750 and the A770.
Yep.
Does that tell us a little bit about power consumption?
It does. Did we say 225 yet?
We
just did.
Now you did.
Okay. 225.
Yeah, 225 watts.
This just in.
Yes.
Does it compare?
The benefit of doing all these live.
And does it compare? Yeah, I know, it's funny, right? Does it compare to competing vendors like?
Ooh, what's a 3060?
Well, I'm just not even that, but like is your 225 total board power? I don't even know if that's what it's called. But does that compare to other? Because everybody sort of has like, peak power and
I think of it as there's going to be a power number. We're obviously not going to violate edge connector kind of power limits or ATX power limits.
Okay.
And there are obviously power transients depending on the workload. Our number is a TDP, which is sort of like a sustained power level we'll regulate to, and without violating any edge specs. It's almost like when you think about TDP, it's like how much energy is being consumed by the GPU that I have to radiate. And that's sort of like, are you going to have a hot room? Are you going to have a cool room? And it goes back to our overclocking strategy, where the power slider that you might see is how you can modulate that. If you want to add some power, you'd add it, and it's all modulating TDP.
Okay. And speaking of power, I feel like sometimes people, we recently had Steven Eastman on to talk about ATX 3.0 multi-rail. Really cool stuff. I think it's pretty awesome because, it addresses the transients that have been unregulated for everybody for a long time now.
Forever.
But for some reason, because Intel came out with ATX 3.0, everybody's like, well, it's Intel's fault that we're going to be pushing 600 watt cards like tomorrow. Like, obviously, A750 is going to need 600 watts.
Well, I did have a mistake. I'm always just sort of staying shit, and I did that a while ago, and I did a little video thing. Do you remember this?
I do remember. Yeah,
where I did a sneak peek of an edge of a graphics card, and it was just during, I think I was talking to Hot Hardware, and I showed the little edge connector, and somebody snapped that video, and they said Intel's launching a 4 or 3.
It was 3 8-pin power connectors on it, because it wasn't the graphics card you were showing. It was like a power testing prototype that he was working on.
It is,
and it just looked at the PCB of it. And so you saw 3 8-pin power connectors, and that was the story
Articles,
of the day. Right?
Intel's doing a kilowatt
GPU,
graphics card, right? So
it's basically sort of the TMZ approach to everything.
Exactly.
Like you're going down, you're George Clooney.
Exactly.
You look like hell. You're in your robe.
I mean, to be fair, it was completely Tom's fault.
Oh no, it was. I don't blame anybody. I take the hit on that one.
He was like, "Oh yeah."
I even sent a note. I rarely apologize for things. I do. I just assume there's going to be some noise, but this time I sent out a note.
But you have to point out that you know what? The day that TMZ does not show up to take that ugly picture of George Clooney,
done.
You're out.
George Clooney is like, "Hey, I'm going down."
Yes, for sure.
Dr. Ian Cutress would like to follow up and say,
all right. God damn it, Ian.
Once again, it's the 225 peak. What's the transient peak?
Ooh, transients. I don't know. I don't have a number for that, Ian, but you know what? When we talk one-on-one, I will have a number for you. How about that?
There you go.
But I have a question.
Okay, go ahead, Brad.
So Pro High Tech, a Russian channel, got a hold of an A380.
Okay.
And they overclocked it by increasing the voltage and bumping up your GPU performance slider.
Yep.
And got quite a sizable gain out of it, actually.
I saw that.
So I just wonder if you could talk about that a little bit. What do you expect from overclocking these cards since we're talking about power?
I think I may have mentioned already that I expect to see some pretty good overclocking. I do think when you look at the UIs, you will see 3 basic controls. There's a voltage offset, which is actually changing the voltage limit, and that allows our graphics card to run a little bit higher up the VF curve, and we unlock a few extra voltage points. That is going to have a long-term impact on reliability of your graphics card. That's why it's a separate slider. The second slider you'll see is the performance slider, and that's what you would expect. It's tweaking the VF curve basically up to basically get better efficiency at every voltage. And then the last slider you'll see is a power slider, so you can add more power. So our cards right now, I would say, are very conservative in their VF curve, which means that you as a user or a purchaser have an opportunity to kind of like play with this a little bit. But you know, it's still very early days for our software on overclocking and all of our infrastructure on overclocking. So I'm not going to claim too much right now. But there is.
But those results are really promising.
Those are really promising so far. Yeah. So what I'm saying is, his review was very promising, and I'm glad to see that. But you know, I think it might be a little bit optimistic to set that expectation for every user. And as things roll out, I would say stay tuned, wait for a little bit more realistic number, maybe.
Okay. But does that mean because I mean, overclocking, you're going to consume more power.
Yep.
Is ARC going to require an ATX 3.0 power supply? Will it take advantage of it?
No.
For the transit? So you'll run on the existing infrastructure.
Yeah.
So you're saying you're not going to be the violator of the 600 watt?
Not in this generation for sure. And I just cannot imagine that that's like the direction we want to go in the short term.
Oh, okay.
Right. I mean, it might be. I mean, as we start getting past Battle Mage into Celestial, maybe we do some of these just like super high end cards, and we do need some extra beefy power to do that. But it's not where most of our gamers are. It's not where most of the market is. So it's not the first place we would start.
Okay.
Speaking of which, I had a question. Most companies don't start at the low end. You're starting by showing off the low end and then kind of coming into the high end. Why that approach?
Well, again, I think it goes back to Ryan's comments about our learnings. And we were basically timing based on the availability of the entry cards and kind of like walk, crawl, run strategy. Let's keep it small in China. And that's where the ARC 3 family has the most appropriate performance cost profile. So that's really what drove ARC 3 first, but I don't think we'd do that again. I think maybe we would someday.
I would not.
Maybe we would, but I do not expect that would be our normal strategy.
Okay. So conventional would be higher end.
And to also be fair, right, I think we would do it again. We would want desktop to lead over notebook.
If we could.
Right? Because it's easier for us to tell a graphic story there that can waterfall down into the notebook and mobile space. And when you start with the mobile, it's more complicated.
All of
you
this
just get more
is
components
good
and
learning.
platforms to deal with.
Think of it as good learning, and you know what, we're gonna get better.
But the fun thing is that means you guys get to come around and talk to all of us.
I actually love it. How long has it been
fun.
since I saw you in person? It's been 3 years at least.
Too long.
Forever.
And Brad, you still got the beard going. I love it. Looks good.
I don't think this counts as in person.
It'll die with
Brad,
me.
though.
Yeah.
And you look like you're in a different room. Like last time I saw you, it was more like a cave-like structure. Now you've got some light in the room.
Yeah, I moved into my living room so I can get the Nice sun in my face.
Nice.
I will say the last time we had you on, Tom, it was remotely, unfortunately, but you were talking about the laptop parts and you were talking about more content creation stuff, and that's where I'm perked up. But now that we're here talking about the desktop stuff, I haven't seen a ton of talk about content creation. So I'm very curious about that.
Good point. Now, do you want to segue to your question?
Because to me the big question is, you have AV1, that's awesome stuff. I think Linus sort of got some of the demo to run. It's cool. But to me, the big question is like, look, AV1 is cool, but what about ProRes? Because ProRes seems to be what everybody oddly cares about. It's
or at least Apple.
Well, but I mean, like
at
Premiere, Puget Bench for Premiere is largely weighted for ProRes support. So I'm like, are you going to do ProRes in hardware?
Okay, like so first of all, thank you for the question on content creation. Thank you for the question on ProRes. They're both excellent questions, which I am not going to answer. No, just kidding. No, I'm not just kidding. Just kidding. I'm going to answer it.
He even has a. Can we go to the slide?
Yes. So first of all, let me thank Charlie Wang, one of our senior. I guess he's actually a PE. He's like a senior PE, which is pretty high up, and he's a media genius.
Oh.
I have great respect for him. So when I saw that you had a question about ProRes, immediately I turned to Charlie and said, "What the hell is Gordon asking about?" Right. So I am not an expert, but I did get an education. Okay, so I'm going to try to walk you through this. You walk me through this.
No, I don't, because let me just give you the backstory, because one of the reasons why M1, M2, and the Mac Pro Tower are awesome is they have hardware accelerators for ProRes, which is a very big codec that happens to be owned by
Apple proprietary.
Apple.
Right. Now, first of all, the way I think about it is there's a camera, and the camera has an output format. So that's like up here at the top. I don't know if you can see it. Yeah. So if you think about it, every camera or many cameras are very different, and they all have these different output formats. So it could be ProRes RAW, it could be Blackmagic RAW, B-RAW, could be Red's output format, and it also could be this thing called Avid DNxHR. Right. And those output formats are usually proprietary. They're usually IP. And that's the case with ProRes RAW, which is an Apple proprietary output format. And they do have IP restrictions on it. We would love to look at accelerating something like that. But I don't believe that Apple right now is calling us up every day going, hey, why don't you guys do that, right? We're not getting that call. So we are actually engaging with these folks at Avid for DNxHR, which is an alternative format with more open approach to this whole thing. And that's likely what you'll see us move forward with. Now, in the middle, after you do the sort of ingesting, there's what do all the creator tools work? And they all have their own data formats as well. And mostly, again, they're in these three places. There's AV1, there's HEVC, and the ProRes 422, which is, again, the Apple proprietary format. We're not going to be supporting ProRes 422 natively because, again, IP issues prevent us from doing that. But we can work with these DNxHR codecs, and I think that's where you'll eventually see hardware acceleration from Intel. Lastly, I want to say that all of these ingestion formats can potentially be accelerated on our discrete graphics. So if we were running EU programs, compute shaders, to do the decompression, that might be a kind of a medium performance solution. So we're looking at all of those, and Charlie is a genius. He's going to figure this all out. And at the end of the day,
Charlie's watching.
Yeah, I hope Charlie's watching. He's going to figure all this stuff out, and it's going to be good. So that's my prepared response.
Okay, because I mean, the funny thing is, because I even though it is proprietary, I think it's fair if it is super popular and that's what everybody uses in industry. But that's the thing is Adam is saying, you know what, it's probably not in the workflow of most.
I mean, ProRes RAW is one thing. And then, editing in ProRes, sure, there are people in the industry that need to take ingest a file, transcode it to ProRes to say, hey, I need a format that's easier to edit with. But I feel like, I mean, a lot of us that I know have powerful machines. We don't transcode. We don't actually put it in that different kind of ingestion. But I will say more PC users that I know are more willing to go the DNxHR route than ProRes personally.
Do you know about DNxHR? Because I didn't know anything. You do?
Yeah.
And is it true that it's like an alternative to ProRes?
Yes.
It is.
Yes.
Okay.
So
excellent. So I'm not lying.
But I will say it's not
to check now.
Yeah. Thank you.
I will say it's not just for easier, lighter editing workloads. It's also popular for backing up files too. Like, hey, you know what? We've delivered the final product, and now we need to kind of like store all these large files. You want to store it in the largest quality. DNxHR is one of those options. One of one of those options. It always depends.
And it's also worth noting, like your original question, more about general content creation stuff, because that's where we started on the notebook side, right? Is that all exists in the desktop products
for sure,
right? So you've got your AV1 hardware encode and decode. Obviously,
HEVC.
you have HEVC. You have support for the deep link feature set. Now it's a little bit.
I wanted to
more,
ask about that.
Yeah, it's a little bit more complicated, right? Because one, obviously, you got to pair it with an Intel CPU. Obviously, you got to pair it with an Intel CPU that has the right graphics enabled on it, right? You have to make sure, we were talking about BIOS options earlier, you got to make sure the integrated graphics is actually enabled in the BIOS to do it. Hyper encode as a feature, the ability to use the encode engines on both the integrated graphics and the discrete works just like we were showcasing in the mobile side.
Works here.
Things like hypercompute are more difficult to show really good scaling on, because the size of the compute engine on the A750 and the integrated graphics is very different.
Yeah, you can think back at the old heterogeneous style implementations that both AMD and NVIDIA did back in the day, trying to work with, like I remember NForce and GeForce trying to do cooperative computing, but the performance of the compute on GeForce is just so dramatically higher that it's really hard to get anything that's like worth doing. And it's the same situation here. We have the added benefit of most BIOSes defeature, like turn off the discrete, the integrated graphics when they detect a discrete card. And so that's also a behavior that we would normally want to change now that we can be cooperative with that device.
But I mean, so you have to go to board vendors and you got to say, hey, you need to think about maybe leaving rebar on because it doesn't hurt anything.
Yes.
And leave the IGP on if it has it, right?
It's just this. These are all the things that we're going to experience as a new entrant into the discrete business. But we're down. We're ready for it. It's just going to. It's going to be. You know, there's lots of things that we're going to be fixing as we go through here.
Okay. So, as far as deep link features go, these first initial reviews didn't look into them very much. They were all sinking into overclocking. They were sinking into gaming.
Yep.
But as you said, the 16 gigabyte card is obviously intended for creators to make use of all this awesome, content creation stuff that you have. So what is actually available for deep link fixtures? Where can people actually use it? Will it be available when these cards launch?
Yeah, well, DaVinci Resolve will be Resolve, right? And you can look.
I've been using that lately.
Yeah, it's pretty good, right?
Yeah.
I mean, all the tools and applications and demos that we showed, that in the roadmap of application support, that will all work with this, right? It's a matter of what the scaling will be on mobile versus desktop.
Yeah, and that's the key thing is when you've got something that's got 512 EUs compared to something that's got 8 or 16, there's not going to be that much benefit from including
the efficiency. You lose a lot of that efficiency.
But HyperEncode is slightly different because there's dedicated hardware that's not that different between the two, right? Because they're at a targeted application. So in those cases, you will see more benefit from parallelizing the encode decode process.
Correct.
Yeah.
So are you reaching out to companies like DaVinci, to get into Resolve and working with them hand in hand?
Absolutely. We have a great ISV team, and they are out every day working with key creator application enablement and also gaming. So for us, the software is obviously the reason people are into this hardware, and we have, we have a huge team whose only job in life is to say, how can our hardware help you? Right, and then how can we help you take advantage of this hardware?
And I would say, Brad, to your point about the initial, as people have started looking at the desktop products, they've been looking at gaming and overclocking and not really looking at the creator and deep link side. And that's kind of what we expected to be the case, which is why we're more focused on gaming this time around than before. Not that the features don't exist, not that they're not important and critical and awesome to have for different audiences, but we know that when somebody gets an A750 or an A770 in their hand, what they're going to look at first is games.
Absolutely.
Dr. Ian Cuttress with another question. Can I?
Is he cutting the line every time?
He's going to get his own briefing, I expect.
Can I deep link with multiple ARC cards in a machine? What's the max number of cards supported by deep link? 16, 32?
Okay, so Great question, Ian. The way to think about it is DeepLink has a bunch of different technologies that are underneath that umbrella brand. There's really three that we've talked about. One is PowerShare, which is primarily in the notebook. So it's one GPU and one integrated GPU and one CPU, sorry, and they're balancing power efficiently between the two of them. That's a DeepLink feature. The second one is HyperEncode, and that's using two encoders. So that's one integrated and one discrete. I don't know. I think it might work if you just put two discretes in there, but it's kind of like I don't think we've ever really tried that, because it's, you know, we wouldn't recommend people buy two Alchemists to plug two of them in to do HyperEncode. Just use the integrated graphics. The third use case is hypercompute. And hypercompute's the one that's interesting with two discrete graphics cards. And I do expect that just to work. Although, again, it's not what I would expect to be the normal use case, because it's all standardized, right? It's all about getting the ISV to, you know, do the software. It's at the application level. Hypercompute is mostly about application level parallelism. So depending on how well they do, you know, multi-GPU support your mileage is gonna vary.
I'm interested to see, you know, like implemented in some of the Topaz suite of stuff.
Yeah,
it feels like that'd be pretty awesome.
I think it would be. I think it would be.
You know, if you don't know, check out the Topaz applications out there. They're very impressive, and the results are pretty amazing.
They are. I love the demos, and the truth is, it just improves the life of creators.
Yeah. No, even for I'm no creator, but everyday people, I upsampled my wedding video.
Did you do any of the image stabilization and all that kind of stuff?
I tried a bunch of the different, because, you know, it was actually shot on DV tape.
Okay.
So it looks horrible,
yeah.
but
and you took out some of the noise and
out noise, and it really is impressive. And then,
cool.
you know, to run it on, you know, an IGP or run it on discrete, honestly, I'm actually excited to try it on an ARC, because most of the time I run on GeForce, because they definitely have a nice improvement. So, you know, but
I understand.
So it'll be cool.
All right. Well, let's see. What else we got? Do you want to talk about chips, or you want to talk about FCS? Do you want to talk about sync modes, or what do you think?
Should we do a summary for the chip? Because maybe not everybody's watched Steve's or
go back to the
videos.
chip.
Let's share the chip details. Can we show the slide here, Adam?
Yep.
Because this is the details that
real geeks, real nerds would love to see.
Real nerds, and they're able to share today. And so you need to explain this to me like I'm a console player.
Okay.
Sorry.
Hey, now, haters throwing some shade.
I am a hater.
I love console players. Just to say that out loud.
All gamers are great.
I love gamers.
It's just don't get in our
easy kills. I'll take them every time.
Just don't get in my grill and say, "Oh, it's better on console." That's my problem. That's where it comes from.
It's okay if it is better on consoles. Consoles are great for things.
So it's good for something. It's better on something. It's not better for
I have a Switch. Proud to say.
Oh, okay.
I have a Switch. I like it. You know.
I think we all do, except for Gordon.
You don't like the Switch?
I'm not a controller player.
You don't like Zelda?
He actually doesn't believe the Steam Deck. He thinks the Steam Deck's a console.
I play one game.
Ryan has a Steam Deck right here. I have pretty good.
I have a Steam Deck.
He was playing the goddamn cat game on it.
I was Stray. I was.
Oh, that
was. You know, a funny thing happened. I was playing Stray on that, and the person next to me leaned over for a solid 20 minutes, just like
watching Stray.
It's a good game. It's a good game.
And the bad guys in Stray, they're the little like pig-looking things.
They
look like the head crabs from Half-Life.
They do.
Oh, is that right?
Small, yeah.
Okay.
Yeah,
wait, they aren't dogs? Because I like
they're like head crabs.
Not
look,
dogs.
I don't want to ruin. Spoiler alert here, but
all right. All right, so back to
this table.
Let's talk about some hardware here.
So what this is telling you is that we've built two chips. There's an ACM G10 and an ACM G11. The G10 is the big chip, 32 Xe cores. The G11 is smaller. It's cut down. It's 8 Xe cores. They both support hardware ray tracing. So if you're into that, which I am, it's got 32 ray tracing units on the G10 and 8 on the G. You can kind of think about the G11 as basically 1/4 of the G10. And we use the G11 in our 3 series, and the G10 is used in the 5 and the 7 series. Both of them support PCI Express Gen 4. Again, we have twice the number of lanes on the G10 chip versus the G11 chip. So when you buy like a 3 series, you're going to get an 8-lane PCI Express Gen 4. When you buy a 7 and a 5, you're going to get 16-lane PCIe Gen 4. I had a question about that come up last time. That's all about perf cost tuning. And the truth is, much beyond a by 8 Gen 4 at that class performance doesn't really do you much, and it costs money to have those IOs and stuff. So this is a more optimal solution. But I don't want anybody to be surprised if you buy like an AIC version and it's got the 128 on it. You're going to see some of those little fingers down below, which you normally expect to see have gold on them, may actually not be present. No big deal.
You know, because oftentimes we've seen other board vendors have shorter electrical implementations. It's still full PCB.
Yeah.
And I imagine, I got to ask you, because you've built these things for many years, even though the card doesn't have a full width PCIe, you still do it full length because you need the boards, you need the mechanical
support. Yeah.
Right?
And our partner board, the first one I've seen is a Ganier board for the A380. It's about that long. It's a very solid board. If you haven't got one and you want one, talk to our esteemed Mr. Shrout, maybe can hook you up. But it's pretty. It's a well built card, and it's about that long. It's got great performance.
Okay.
All right. So last thing is it's got full media engines on both. So that's the media that does the AV1 hardware encoding, and it's got great display on both. So 4 pipes, which means it can support 4 simultaneous displays, and it goes up to I think 8K at 60 and 4K at 120 hertz. Per head. So it's like feature amazing. And when you couple these XE cores, let me tell you really quick about the XE cores. That's our fundamental compute unit, and it's made up of render slices. And these render slices are basically, render slice contains XE cores, and that's where you'll see our vector unit, our matrix unit, all of our ray tracing units, and all the fixed function things like raster, geometry, and high-Z. So it's a very traditional look, but you got to kind of dive into the XE core to really see the parallelism that we've built. These things are just compute monsters, and it's what we're using to do XeSS. So I don't know if you've looked at XeSS yet, or if you've heard about XeSS.
Why don't we explain it?
I was going to ask you about that. Would that be available at launch?
Oh, yeah, baby. Really? Yes. Yeah. So when you say launch, what I'd like to clarify is that there's going to be a date that we're going to say these are available to buy today. We might say like buy 2 days from now or whatever we need to do for a channel. It's not going to be like there's a launch and then you wait for like 4 years or whatever, and then because there's what's the point of that? So for us, you're going to hear, hey, these are now available at Amazon, Newegg, wherever else they're going to be at ETL and retail. And we do expect XeSS to be available in launch games on or about that launch date. It's also, of course, up to the ISVs. It's up to the software guys to decide when they make their game available. But I happen to feel very confident that we will, due to the great work of our ISV enablement team and our dev tech team, and of course all of our partners, I'm pretty excited. I'd like to say a special thank you, if I can, to the XeSS team inside of Intel, who have been busting butt to get this to work. And when you see it, it's amazing.
So you think, because I mean, let's be honest here. For people who don't know, XeSS is, if we're going to speak in green speak, DLSS. Well, I know that's the only way people can only understand when you speak of it. Like it's you got to say it's got to be like this. So it's your compute based super sampling, awesome stuff. How is it going to stand up against DLSS?
I feel very confident.
Okay,
I feel very confident, and I've looked at it in detail. And so the way I'm so confident that we are actually making XeSS available to run on competitor hardware.
Huh.
I know.
Wait.
Yeah.
So you buy a game, you can go in there, you have a GeForce or a Radeon, you can go and click on XeSS if the
ISV enables it. So effectively we've done an open approach to this where we have a multi-vendor implementation using DP4A. So DP4A is present in most GPUs, which is just sort of like a parallelized vector operation. And we have a version of this that's running a smaller network. So it's not as full-featured as, say, the XMX accelerated network, but it's smaller, and that means you can get good performance on hardware that doesn't have native systolic arrays.
So what's the rationale for
why would we do such a thing?
Yes,
I've talked to many people about that. And here's my thinking. We're new. right? And what we really want is support from a broad collection of ISVs. And the best way to get that is to say, listen, XeSS is not just about our installed base. It's about the entire gaming installed base. So if you adopt this technology, it can be deployed on the existing infrastructure, right? So, and the other thing that's important is that same infrastructure includes integrated. Right, so our XeSS solution, DP4A, works on integrated graphics, and all of a sudden you're talking about not our I hope to be hundreds of millions of discrete GPUs. We're talking about billions of installed base of integrated graphics. Right now, your mileage obviously is going to vary because some integrated graphics is pretty low performance, but as you get more modern integrated graphics, XeSS is going to be a really nice uplift for Intel-based graphics. So that's our strategy.
So in that fallback mode, the DP4A, I find that super interesting. I can't wait to test it on integrated graphics.
Yes.
In the fallback mode, the DP4A mode, does it still use all the motion vectors and stuff like that, just like the full-fledged implementation?
Well, it's a different network, so you can think about it as a lighter network because obviously there's not as much compute power. So the XMX accelerated network is big and it does better at edges. It's better noise reduction, has less flicker, but they're not. Who's the guy? Digital Foundry guy? What's his name?
Richard.
By the way, love you. Love your work. Good job.
Oh, he's not watching us.
Yeah.
He's got better things to do.
Still a good guy. And anyway, he would know right away the difference between the XMX and the sort of the DP4A implementation. But most people are going to say the DP4A implementation is pretty darn good.
See, the problem is with Richard, he can see the difference, and it's better just to have I have McDonald's taste. I can eat anywhere. If he's like, oh, I gotta have this, whatever Wagyu steak that's 95 minute massage for 6 months, he's gonna have problems.
He's a great guy. I love him.
No, I love him.
I love him. All right, so that's XeSS.
Real quick, I do have a question from Ian. He says, "Can we?"
Is this the same?
It's the same Ian. Tell him to get in the back of line.
It's Ian Jones. It's not Ian Cuttress.
He said, "Can we confirm if it's the X and the E is pronounced EX or I'm sorry, XE or Z?
XE.
It's been okay.
XE.
So
by the way, what is the TI pronounced as?
TI.
Yeah.
Yeah, it's TI.
I know. I've heard of it.
Are you sure?
Yeah.
All right.
Yeah. That was my answer too.
Okay.
I can't talk about it.
So to the screen.
Yeah. Do you want to do the sync stuff?
Yeah, or do we want to show actually the you talk about DP4A and you talk about the X?
Oh, you want to show that block? I don't know if I have that block here.
Oh,
I think I deleted it.
Oh, no, not that one.
Which one? This one? Or are you talking about the one
about the 16X?
You're talking about the one with the whole
big old matrix?
I took it out.
I took it out.
Sorry.
That's all right.
It's just so complicated. I felt like it would be too much. But maybe I'm sorry. I'm sorry. But maybe I'm sorry.
For people who are missing it, somebody did a XE HBD architecture deep dive on PCWorld.com. You can go find that slide there.
Oh, very cool.
Somebody did it.
Was it you?
Nice. Somebody did it.
It's somebody.
Good job, Brad. Did you use that picture?
I did, and I embedded your video from you here last time.
Oh, nice.
Because I'm actually very excited to use an ARC card for, again, doing using Topaz, doing this sort of like AI based image manipulation. I think it's just the coolest thing ever. So I think I'm actually very excited for that.
This team has left it on the dance floor. Okay, they've been working night and day, the driver team, the hardware team, the board team, and we're just so excited to get it in the hands of real users and start getting some real feedback. So please give us the feedback.
I do have a question for XeSS because for let's say a competing company will say, hey, we've got X titles. We've now got X titles. We've doubled it. Is it going to turn in one of those games where you got to have this many titles and they got this many titles?
No. The truth is, Gordon, I think this whole space of post, which is what we're talking about render, do some render work, and then do an effect after it. It is just begging for standardization. It's saying, we don't really need 5 different APIs for this. We don't really need we don't need an FSR API. We don't need a DLSS API. We don't need an XeSS API. We need one API that hopefully Microsoft would do, and then we could all plug in underneath. That's what I would love to see. Now, until that happens, we're going to keep doing what we got to do to be competitive. But the truth is, we, Intel, would love for this to be standardized. How's that?
Would you have to open it up then, or
yeah, you would. We would basically the way to think about it is if we do the API correctly, and I have looked at this, we can have an API that works across many different post effects, and it basically is
not just AI upsampling.
Yeah, not just. There's a lot of things that are similar to this that we're working on that I would love to basically do one API, and we plug in effects underneath that, right? And so could NVIDIA, so could AMD. It just makes so much sense. It would make the ISV's life easier, but it's hard. Right now we're talking not just 2 companies, we're talking about 3 companies, or 4 when you add Microsoft. So agreeing on a new thing that's this important to all of us is going to take some time.
Yeah, and then to be honest, if you're a company and you're ahead of everybody else, you sure as hell don't want to give up your lead.
Yeah.
So why would you?
Although I happen to know some of those green guys, and they're very good human beings, and they're actually already thinking about that kind of standardization, because it's just so good for our ISVs. It's good for the PC platform,
right?
And it's just the right thing to do.
Yeah, I did notice those green guys put out that tool for ISVs to be able to easily implement various
what was that called?
Solutions like this.
Stream something or
Stream something? I forget. I didn't research that, but you guys were on board right there on day one.
And I still am, and it's just because it's just such a obvious thing that would help the industry, and I would love to be able to innovate quicker underneath that standard. Right now, every time we do a different effect, we got to go back to the ISVs and say, "Good news for you, we got a new API. Rip up your engine, make some changes." Right? They don't like that. So that's my rant anyway.
No, it would be, and I think sometimes the community has a hard time understanding. It's a big fight, and then finally everybody's like, okay, now it's time to settle.
Look at DX. DX is the thing that helped us move from, and I should add OpenGL and all the rest of it, but those standards are hugely important to building a software ecosystem that people are willing to invest in and get better. And look at games today. It's freaking amazing, right? But all of that came from standardization. And that's where Intel is like, this is our thing. We know about this. PCI Express, USB, SATA, ATX. I mean, come on.
Yeah, no, and it's fair. And I always like to point this out to the community that Intel has basically created all these standards, and you often don't get credit for it. I know I'm sounding like a shill.
No.
My shilling.
I don't want people to credit us. We all benefit from a common open platform. And this technology, the super sampling technology, is not any different.
No, I like that approach. It'll be interesting to see how long it takes to fight it out. But
do some blogs.
Okay,
do some blogs. Talk to some of your Microsoft.
I can't get people to move away from ATX.
People.
So.
Yeah,
that's what I always tell Gordon too. Hey man, do some blogs.
Definitely.
All right, what else do you want to talk about?
Let's get Brad. You want to go, because we definitely want to do the sampling stuff, which is tough for the audio listeners, but we will try to describe it because this is an audio podcast.
Oh, the sync stuff.
No, go ahead. Go ahead with the sync stuff.
So we're gonna. Is there a slide to show first?
Yes, there is.
You have speed sync. I was calling it fast sync for some reason.
I know why you were calling it fast.
And then smooth sync.
Yes.
And if I understand it right, so speed sync, you show the best frame,
the most recent
frame of all the tearing.
I don't judge the frames. It's just they're all great.
Okay.
They're all great. We just show the most recent one.
The latest one. So basically when you're getting the tearing, you get rid of that and you only see one frame, so you don't always see it.
Yeah, you don't see all the flickers. And this is a technology that's very good when you have a very high render rate. So if you have lower render rate, it's kind of, it doesn't do anything if your render rate's below the refresh rate. So when your render rate is above the refresh rate and it's very close, then it kind of sucks because you're just sort of dropping frames and then you're starting to hitch and stutter. So you got to really have high render rates to make this technology work well. So that's things like CS:GO and, maybe depending on your card, things like any esports titles.
Right.
That's really where this technology excels, because by doing this and dropping all the other frames, you get no tearing and your latency is still very, very low. And the alternate that a lot of people do today is they turn on VSync if they don't want tearing, but that is terrible for your latency. So this is kind of in the middle. It's not a panacea, but it does make games have much better latency when your render rate is very high.
So this will simply work on any game at all.
It will work on any game at all.
On Arc, discrete as well as, I guess we could see that migrated.
Maybe. I mean, we'd have to get a really beefy integrated GPU to make this do something good. True, but right, I mean, sure, good.
Huh, if your integrated GPU is spitting out 300 plus frames a second, that's a pretty big CPU you got there.
I don't want to claim that there's a future heading with higher performance integrated GPUs, but someday.
I can see it getting there. It's so, but I mean the appeal of it, because I mean a lot of people, they just simply hate the tearing.
Yeah,
they're running a high end card. Yep. With a 60 frame VSync, and like, what the hell is the point of buying your high end card?
It's kind of sad.
And a lot of people really do that. I mean,
I know. That's why SpeedSync's here.
Huh.
Yeah. Now the other technology, SmoothSync, is brand new. Never like had a brain hatch this before. So it's not my idea, by the way. This is a guy named Gary Smith, great guy. He came to me and said, we've got this thing we've been working on, SmoothSync. I'm like, really? Let's take a look at it. And it's pretty cool. Can I show you a picture?
Yeah, let's look at it.
All right. So the problem. Basically, the tearing comes from the fact that there's a render happening on the GPU that is asynchronous with the refresh rate of a panel. And panels actually refresh by drawing lines from the top to the bottom one at a time. And so what's happening with a tear is you're starting to draw one frame, and then when you get about a third of the way down in this picture, a new frame gets rendered. And so now you got a choice as a graphics architect. You can say, well, I'll just wait for the next frame. I'll wait for this refresh to finish, and then I'll show the new frame. Or I'll just start showing the new frame right now, which is what happens when VSync is off. And that's why this thing's tearing. It's actually showing you two different rendered frames with motion. And so the bottom,
it's painful on his skull.
In this picture with the skull, the top half is drawn first, and so this is a camera panning from the left to the. I guess it's panning from left to right, right?
Right.
Yeah. So that's what tearing is. Now, what SmoothSync does is it says, well, instead of just tearing, why don't I blend across that boundary? Because I know where both graphics renders are, so I can use a stipple pattern or some kind of dithering to make that boundary easier. And Ryan just told me that he just tried it.
I did just last week, tried it for the first time. Found kind of one of those, the frame rates like 58 FPS kind of thing, where so you get a lot of scroll, where you get the scrolling tears as well, all the way up and down, and it's great. Yes, gross. It has the effect of blurring it and kind of minimizing the impact of what you're experiencing.
It's really cool.
The tearing still happens, right? Like it's not solving it, but it blends it in a way that does so. And we've got like some video to walk through.
Yeah, let me show you the video here. It's pretty cool. So this is just a random game capture. I'm not going to name the game, but you can see on the left this giant tear line. I'm going to use my cursor. So this is the tear, and I'm using a program called VirtualDub, and I did a hardware capture. We put it side by side, and so this is how you can actually look at a tear one frame at a time. So if we go forward, you can kind of see.
Find an example where you can see a tear on both sides.
I'm going to see a tear on both sides. I would say, is that one?
No, you see that one.
Yeah, you
can see it up here. Okay,
up there,
so in this, they're not quite totally in sync. So look at this vertical bar on the left. You can see the wall tear, and then you can see like the whole city's tearing with all these vertical pieces. On the right hand side, the tear's happening up here. So you see how the wall is coming down straight, and then there's like this weird like blend, and then it keeps coming, but it's at a different spot. That's what SmoothSync is doing. And instead of being this this harsh tear line, your eye is going, well, maybe it's a tear, but maybe it's not a tear. But it's definitely a tear. It's just that it's less of a tear. And if you look at a couple different frames,
if you look at the green tower in the back, it's really dramatic how much difference it makes.
Let me see if I can get that to tear.
By the red thing.
By the red, there's a big tear. So you can see here again, pretty dramatic on the left. It's still pretty big right here because that's like a giant tear.
It's super high contrast.
Yeah, but in the middle here, you'd say it's not so bad, right? It's kind of weird. And I think that's the idea. I think people are going to, some are going to love it. Some are going to be like, I don't get it. But look down here at the bottom. Right here is a massive tear. There's this like lady cut in half. And on the bottom, you're like, I mean, it's a tear, but And when you see it in real time, your brain doesn't like fire as quickly, and your brain's not going, "That's a bullshit tear."
Right. It just doesn't. It's so jarring, which is why most people like, okay, I got to turn VSync on. I can't stand this.
Yeah.
So
this is again meant to be. Maybe there's a middle ground here. Maybe some people are going to be. It's going to be less painful to the degree that they're going to run with VSync off, and they're going to better latency, better frame rates, better action.
And cool about this feature is that it is game independent. It is display independent, and it all happens in our display output hardware.
Yeah. Yep.
Right.
It's really smart.
So this would be perfect for esports. You know, again, you're pushing, you know,
there's lots
of frames a second.
Lots of options here. When you push 100 frames a second, you're going to see, or let's call it 200 frames a second. You're going to like 3 or 4 frames at the same time. So everywhere you look, you see this sort of like little stipple, like tearing lines. With SmoothSync, all of that would be sort of blended together and hopefully be less jarring.
So you just switch that on the driver then?
Yeah, it's in our control panel.
Okay.
Yeah.
I'm super excited to test that. I can't wait to get my hands on the card to test that feature specifically because I hate VSync. I hate the way it feels.
Yeah.
Obviously, not everyone has an adaptive sync monitor.
Yep.
And that, I think, would do just well enough in my brain to make a huge difference.
I'm glad to hear that.
Just well enough for your brain. I like that qualification of it. It's just good enough for my brain.
All I need is just a little bit more, and I'll probably be okay. That's the way I always.
It really is. I mean, sorry, audio listeners, but it really is like just looking at the video. You don't feel it as much.
Yeah.
I can't explain it.
It's like when I did G-Sync. You can, you know, talking to people about G-Sync is sort of theoretically you get it, but until you see it, it's very hard. And the same thing, by the way, is true with adaptive sync.
All display technology, HDR, right? Like HDR, trying to describe and show HDR displays and it's the
totally
variable
impossible.
refresh stuff.
Totally impossible.
But you're right. It will be a personal taste thing because
of course.
I did a blind taste test and there were people who preferred 60 hertz. I was kind of blown away. Remember the original 120 hertz panels? I was like, what? How would you? Yeah. What is wrong with you?
Yeah.
You know, the world is, there's
should get
different
checked out.
tastes for.
Yep.
Yeah.
You should get that looked at.
So is there a performance penalty to enabling that? I mean, it's got to, something's got to happen.
It is inconsequential. I think there's like one scan line of additional latency, which if you divide, 60 hertz by some number, it's a tiny number. But yeah.
Good detailed explanation.
Yeah,
I like it.
It's a tiny. Let me just say it's a tiny number.
A smaller number.
Maybe Ian, can you paste the actual number in the chat?
So
will that be available day one as well?
Yes, sir.
Oh,
awesome.
Interesting. I mean, it's kind of cool because, I mean, both of these features are really just like, why the hell didn't somebody think of that before?
Yeah, that's the way most of my stuff is. Although, again, this is not my stuff. But yeah.
Why? Well, I mean, it's...
you got to think about it. Everything's like that at some point.
Yeah, everything. Yeah.
Everything starts out way.
Oh, wow. Ian did paste the number in.
There you go.
And what was it? What number did he come up with?
Small number.
0.00547%.
Thank you. Thank you, Ian.
I'm just surprised because you would
hopefully that's okay for everybody.
Yeah.
Hopefully.
Small.
I mean, it's his livelihood on the line. So.
Yeah, but why? I mean, like, why have? Well, you're right because first time. I just don't understand like why the hell nobody else has done this yet. But
listen, I don't judge. I don't judge. I love all people.
Okay.
Yeah.
I mean, and again, that's like a really big plus about having a third player because it's good to have more competitors in any field, right? So
if you look at any of my patents, you'll see most of them are like that shouldn't even be a patent.
That's not fair. That's obvious.
That's like most of my patents.
That's the color blue. You can't have a patent on that.
I actually have I have a pretty good patent. You want to hear about it?
Yes.
All right. So not only am I on the G-Sync patent, which is pretty good, but you will see my very first patent is I used to work at IBM doing CPU design, and we there's this thing called the MESI protocol that everybody uses for cache coherence even today, and I invented exclusive intervention. Yeah. So basically the idea is when you have a line exclusive in one cache and somebody reads that same line, you can transfer it to the other guy without going back to memory. Yeah. Seems obvious, right?
That's, You
don't have to go get the same thing a second time.
Yeah, because, that's just, it seems pretty obvious, right?
Yeah. Yeah, that seems too obvious.
Yeah, see?
Like, what? That's, like, hey, I'm going on vacation. Who's going to be taking over the patent office?
Yeah.
I don't know. Bill's going to do it?
I got Bill when the thing came in there. IBM will patent anything.
I guess, we'll give it to him. That's IBM. Must
Sounds
be good.
Sounds good. Seems like a good guy.
Slide to unlock. There's a patent for slide to unlock, right? I think so, right? Because it was a huge...
There is? Really?
There's always something. Like, really?
Wow.
Yeah.
Yeah, go look it up. It's pretty funny.
That's funny. So what can we say? So so obviously this is again awesome stuff. When can we expect 7 series?
Okay, here's what I want to say to that. I cannot answer that question.
Okay. Before the end of the year.
But I will. I really, you know what I've learned is that every time we say something, people remember what we say. And we set expectations, and if we don't meet them, we disappoint people.
Well,
right?
That's why you should be an analyst or journalist, because we're wrong all the time. People are like, "What? I don't even I guess."
No, I give my best estimate of when things are going to happen, because that, you know, it's all imperfect information. We're like, based on what we know right now, I have a very clear date of when I expect this to be on the shelf. I just can't share it with you because I don't want to disappoint people if it changes.
Okay.
So at the end of the day, I would say both sooner than you expect and not that far away from my perspective.
Okay. Just, you know, it's a classic, if aliens land tomorrow, like, we're not going to deliver because we're
although I would
spice
say
mines.
it would be kind of stupid if Ryan and I mean, we do stupid things all the time.
Sure.
But this would be exceptionally stupid for us to go around talking to key press and technical people if we're like in the distant future, right? That would be shockingly stupid.
Okay.
More than I'm used to. More than I'm used to.
which
and I
has
see
been
a lot
shown
of
to be a lot. Yeah,
I see a lot of stupid. Yeah.
Is there any expectations we can set on pricing at all?
I did already say that I think we're going to be, for the titles that we talked about, the ones that are optimized, we're going to be around 20% absolute performance win versus comp. And in comp, I'm saying a 30-60. Now, I've also said across the vast majority of titles, we're going to be a perf per dollar winner. Right.
Okay.
So you're going to get a very good perf per dollar story versus comp, and our numbers are MSRP. So that's what I'm saying.
I kind of have a follow-up question to that touches back on something we were talking about earlier. So you guys are pricing them around, or price per perf around those quote unquote tier 3 titles.
Well, think of it as the total delivered experience. Yeah.
Yes. Okay. So obviously, those DirectX 11, DirectX 9 games, you guys are going to be working on those, getting better at those
forever.
Presumably, you know, like next gen Battle Mage will continue working on that as well. Could we expect, if we buy an Alchemist card when it comes out now, for those optimizations like that come up for Battle Mage to get backported to continue for as applicable?
Yeah, that's a great question. So, Brad, the way I think about it is we've learned so much on the architecture front by doing Alchemist. All of those like just things that we would do different are being rolled into Battle Mage, and maybe earlier. You know, who knows what our real product plan is? I don't know, but it may be that. Certainly, we're making architectural changes to make software compatibility easier for legacy titles. But independent of that, we're also making driver changes to catch up to performance on DX11 and DX9. And that stuff is all going to happen on Alchemist before Battle Mage. Right. So don't think of it as
you don't have to wait till Battle Mage to get the improvements on Alchemist.
Yes.
You will see those iterations occur as our software and driver roadmap.
Yeah. Without committing to anything specific, we do realize that DX11, DX9 are very important to our customer base. We're going to be working on that urgently. Right away, immediately, right now. There's people busily. There are people typing right now, Brad. Feverishly.
Are you guys targeting esports games and stuff like that first?
It's
the more popular games.
So our title list actually comes from a sort of like semi-sophisticated thought process. I'd say we look at all the games that reviewers run and we rank it by like how important are these titles. Then we look at the Steam surveys and we say what are the popular evergreen titles that we want to make sure we nail, and then we just kind of keep whittling down that pile. By the time you've done those two things, you're already over a couple hundred titles, and so we just got to keep working through the list. And hopefully there's not like a lot of things that are just for one game. Hopefully it's like optimizations that lift all boats. And I happen to know a few of those optimizations that do, really lift all boats.
I mean, it feels like that's already probably 80% of the games people play. So.
I think so. Yeah.
So they used to use a term fine wine for Radeon cards back in the past, but it kind of feels like if you guys are going to be working on DirectX 11 and DirectX 9 so hard, these cards might actually age like fine wine.
I don't know, Brad. I don't want to make any commitments, but I feel like we're gonna give gamers every reason to want to kind of become part of the ARC family. Right, and that's a big thing. That's a lot of work we got to do. We got to do it over a long period of time, and people are either going to like the sausage or they're going to be like no bueno sausage, right? So we're going to do whatever we have to do eventually.
So to me, that's like the hardest part of Intel getting to this as the new kid in town. Is we talk to a lot of people. We give a lot of buying advice to friends and family, and like to a T. I've said this before, and I won't ask you to change my mind here. Is generally, if my son or daughter's friend says, "Hey, what video card should I buy?" I'd have a hard time saying buy Intel, because frankly, NVIDIA and AMD are very much known quantities. They're mature. Should that kid really, what can you convince me to tell a kid buying ARC over buying
I wouldn't try to convince you. I would basically say we're gonna start, and we're gonna enter the market. We're gonna prove ourselves, right? And maybe you don't recommend Alchemist, right? But I do, and I would say that the perf per dollar that we're gonna give people should help them be motivated to, hey, let's give it a try. If it doesn't work out, I don't know, it suck, but it's a perf per dollar value. Over time, as we deliver on our commitments and we demonstrate that we play games great and we're giving compelling features, then maybe Battle Mage, or maybe even something in the middle, or maybe whenever. But when you are ready to recommend it, please give me a call and I'll come out. And then you could say, Tom, today's the day.
It's again, because honestly, that's why I'm so glad that you were both on this tour, because it was like, whew, I don't know
what's going down.
What is going on here? And then, honestly, there's a lot of really awesome features here. Again, the content creation side is awesome. You're right. It could get better. You're going to get performance.
I hope so.
As time goes on, probably.
I hope so.
And that's like, I think the content creation point is a good one to have, right? Because we talk about we're gonna price it competitively, great value across a broad set of titles and games, but we have other technologies, we have other capabilities that are differentiated.
There's upside,
right? But we're also like, we're not going to come to the table here and go like, well, you owe us $50 more because of feature X, right?
No.
We've got to do a little bit extra to get into this space. We've got to do a little bit extra to get credibility with the audience, to get people to trust us and want to buy these products. And that's what we're doing. Strategy we're putting out.
Yeah, it's 100%. We know we have to earn trust, and it's going to take a long time.
Well, no, but and again, kudos to you for having this approach, because it really taking the being humble, and it's the way I think to take it,
Gordon. Right? I think we said this last time. Nobody normally says nice things to us.
And that's unfortunate, right? You carry, I always use the analogy, if you're the Patriots or the Warriors, not the Celtics. You say, sorry, Brad, but it's people want to hate you. People want to hate.
I don't want to be hated anymore. Can we all get along?
They want to hate on you. They're always going to look for a way to dump on you. But ARC, interestingly, the community has been very much pulling for Intel here.
I think so.
So I think that's kind of like people want to see, like, oh,
there's a little wind at our back, maybe.
Yeah, but this is pretty cool. What you could say is like, we got RGB. We got better RGB than everybody else.
I could have said that. That would be less good, right?
Honestly, that's probably what sells 80% of computers.
No, it is not. No,
fans and cases, maybe.
That's just you. Remember, we already talked about the shoes ear thing.
I think if you were to if you could do a scientific study where you had hey, we're giving you way more performance out of this box with no RGB, and just the worst box ever with all RGB, and you price them the same, the one with the RGB would outsell.
Man, it's a good thing you're not a product guy. It just would be a disaster.
Definitely
disaster.
Speaking of products, so we got a lot of questions. If you don't mind getting to some,
let's do it.
Most of them are from Ian, but I did call the list a little bit. I'm sorry.
I got to call.
Thank God. Can you send him a note?
You know what? These are good questions. His first one, just recent, said, "Will there be a free game with every ARC card sale, like maybe Stray?" You'd sell out of all of them.
Oh, look. I'm not going to step on our ISV team's toes here and make any kind of announcements.
No promises
for any of that, right?
Okay.
My discussion of that game is not an endorsement from Intel or Intel in any capacity. It's simply what I have been playing.
What are you playing, Gordon? What's your current?
I play World of Potatoes. Which
is that a thing?
It's World of Warships, which is basically a bunch of potatoes
that are floating around,
cruising around. But the scary thing that I've realized is if everybody in this game is a potato, then maybe I am one too. It's really this. Because why am I
self-realization coming through? Huh?
Yeah.
Introspection via video game playing.
It really is why am I doing this? But I can't leave it. So.
I see. And Brad, are you playing anything common often?
I play random stuff. I just picked up Stray. I haven't had a chance to jump into it yet, but I play a lot of Forza Horizon 5 these days.
Oh,
it's the perfect summer game to me.
Yeah, that's pretty good. That's pretty good. All right.
Good. Another question from this one. I'm going to try to cut it up a little bit. From Segi Mitsu. I'm sorry.
All right.
Yeah.
Thank you, Segi, for the question.
Have you tried the DXVK DLL swap for DX9 or DX11 games?
Ooh, so I think you're referring to things like DX on Vulkan.
Yes.
Yes.
I have not tried that. I don't know if we.
I haven't. I don't know. I don't.
It's not a bad idea, right? I just have not tried it. Now there are lots of big lift kind of things happening, which is take an older API and translate it to run it on a newer API, and some of those techniques may actually bear fruit, right? They may actually be very good. But I am not.
I think Microsoft's been pretty open about 9 on 12.
Yeah, 9 on 12 is the thing, and there are other things on things, and like this 9 on Vulkan idea. And I hope someday to be able to say that some of these things are good. I can't do that today.
It would take actually resources though, engineering resources.
It would, which you know what we have.
That's true.
And so does Microsoft.
So does Microsoft.
Right?
Yeah. And we have the will. We have the way. We have the people. We just got to step up.
Huh. Yeah, no, really, that's a good point.
Going back to an Ian question, has Intel allowed the overclocking team, either Dan or Alan G/Splave, put these under the liquid nitrogen yet?
Well,
Ian, I don't know if that group has seen these products yet.
I can say I do get a lot of feedback from a few of them. And
well, I know specifically the names that he's talking about are CPU overclocking.
And they're up in Jones Farm, right?
I think so.
Yeah,
actually, I think so.
Yeah, because I've been up there.
Yeah,
and I can say that they're excellent at what they do. But yeah, they have not played with Arc yet. Maybe we get it up there. Maybe get up there.
All right. Switching over to the Discord questions, because we have some over there. Let me switch that. This one comes in from Borea Zero. Since Alchemist is more of a prototype, when can we expect Battle Mage?
Well, that is a snarky question, but thank you for that. Let's see. So I would say Alchemist is not a prototype, and it is a great sort of performance graphics card, 3060-ish. It's going to have great frame rates, and you're going to get a nice spread of perf per dollar across the whole stack. So, I mean, I get the vibe. And it is likely going to be things need to get fixed, as we've already described, but it's way more than a beta. But there are a lot of things that are going into Battle Mage, microarchitectural things, architectural things that are going to make Battle Mage better. Remember, we have a lot of learning to do, and the way to learn is to do the first one. Right, and we have to learn not just in drivers and microarchitecture and chip manufacturing, but GPU businesses. Like we're like, hey, did anybody talk to the board vendors yet? Yeah, we have to get a whole new distribution and a whole new learning about how do we participate. Yeah. So there's just a tremendous amount of learning going on, but it's definitely not a beta, definitely not a prototype.
Oh, okay. Going back over to an Ian question. Isn't the memory bandwidth on the ACM G11 comparable to a high-end desktop PC? Wasn't it 144 gigabyte per second, a lot lower than an M1 or /M2?
I think I don't know.
Deep questions.
It's a deep question. I will have an answer when I see you.
Okay. How about this? Ian asks, who is Gunir? Or Gunir?
Who's Gunir?
Is it a China-only Intel vendor? Who is behind them? Do they have any history/expertise with GPUs?
Okay, so Gunir is a AIC primarily in PRC. And they are affiliated with another larger company, but I don't know if I don't.
As soon as you said that, I was like, I don't know if we're allowed to say.
Yeah, I don't think
they're affiliated. They have GPU experience.
Yes,
right. Gunir is not coming in full blind, right?
Yeah,
they are a subsidiary, and they know what's happening.
Yep, and they have a wealth of GPU manufacturing experience and design experience. So we're just excited to be partnering with them, and they're doing a great job so far.
It feels like I've seen that brand before. It's not like it's
Gunir also had a couple DG1 cards.
Yeah.
Okay.
What sort of cadence are you guys looking for release? Are you guys looking like some of your slides? Are you guys aiming for a yearly maybe cadence for new GPUs?
Oh, you're talking about our roadmap going forward?
Yes, roadmap.
I think it's premature to talk about our roadmap right now because honestly, if you look at our architectural roadmap, we've already described sort of an Alchemist, then a Battle Mage, then a Celestial. And I don't know if they put years on that, did they?
I don't know. Yeah. It depends on the visualization and the slide each time.
But I would say it's typical if you look at competitors that large architectural changes are not happening every year, right? There's just too much work to do even for the existing suppliers that are already in the market. So I think every year, probably not going to be doing a major architectural change. You could look at what other vendors have done in the past and say, well, you know, kind of got engineers, they got, you know, they got designers, they got chips, they got, you know, probably going to be similar, but I don't know.
That makes sense. Some of the roadmap things you had in the past kind of had 2023, 2024 for Battle Mage, and then 2024 plus for Celestial. And so I've seen people online saying that means they're going to put a GPU out every year. So I just wanted to ask that on the record.
We may put it kind of like, again, if you look at our competitors, they do put out a GPU every year. It's just not a new architecture every year.
Right? Yes.
And so I would say that that's a model that doesn't seem stupid to me, you know?
Yes.
What a nice way to put it.
Yeah, that doesn't seem that doesn't seem that.
I mean, that doesn't seem like
stupid.
an idiotic thing.
And Fish, I apologize. So, I wasn't talking about you.
All right, I have a question from where did my notes go? From the chat of Vipitus. Why does the mobile A730M have more VRAM than the A750M or A750 non-M?
You mean what
does it? Does it? So the A730M, I believe, has 12 gigs of memory.
Interesting.
Yeah, and you don't have it on here.
I don't have it
on this one.
I'm going to defer to Ryan on this.
I mean, I don't know, right? I mean, as you look at our mobile stack and the desktop stack, they're just targeting slightly different product lines, right? I think if you look at what the competition is in that space, it probably made more sense to do it there. But and then I think the A770M has 16 gigs. In the mobile space.
Is that right?
I think that's the case.
I just don't know.
Well, now I got to go look. So
he's going to dig it up. Let's go on the next question. We'll dig it up.
All right. Next one from.
So I have a question. What kind of insights has launching mobile first given you guys for your desktop launch?
A lot. It's all about, you know, how do we help people understand the performance of a mobile product because they're very much determined by the platform, and what we've really learned is that on mobile the power envelope for some of these platforms really doesn't allow the GPU to run at its highest performance, right? Yep. So I think what I've learned is that I'd rather not do that. I'd rather have people start and you know experience the full capability of the GPU first. But again, for us, mobile is such an interesting opportunity, Brad, because you know we are the CPU and we are the GPU and the chipset, and there's got to be benefits that come from that integration that we haven't been able to unlock yet. But I can tell you that some of the brightest minds that I know are working on this problem. And I'm confident that when we get to our next generation of mobile platforms, you'll see, hey, how does this GPU really want to intersect the platform? And that's really what the mobile strategy is going to be all about. It's more of a platformization. Desktop is different, where, you know, you've got this like GPU that's already got a lot of complexity to it. You want to get it out. You want people to understand it. But tying that to a notebook OEM at launch is just very difficult because their platform's moving, our GPU's moving, and everybody is just, man, I wish this was simpler.
It's a lot more of a timing thing. Yeah. By the way, can confirm the specs of the A730M is a 12 gig GDDR6 memory and 16 gigs for the A770M. Okay. And you tell me if this is a dumb answer. I'm just going to speculate here. Yeah. This is Ryan's opinion, not Intel's opinion. Lower TDPs. We needed to get more performance out of it, so that I think that memory configuration allows us to get more memory bandwidth.
I think I love that answer.
Oh, I see.
I love that answer.
Because of it. I was thinking it was just simply cynical marketing.
Yeah, I have no idea what the truth is, but I loved his answer.
Because there are honestly, you know, it's a classic, let's just put more memory in it and the consumer sees more memory.
Apropos of nothing, Intel does a lot of research.
What does apropos mean?
Apropos of nothing. It just means it kind of doesn't really have anything to do with what we're going to talk about, but I'm going to say it anyway. We've done a lot of like research studies and consumer research studies and stuff like that, and the number one specification that people who buy graphics cards look at for the general consumer, not enthusiast consumer, not people that listen to this podcast, is memory.
Right.
Memory capacity.
Wow. Yeah.
Right.
That's why I kind of like.
Yeah. No. And so I get why you would have you can have that cynical take. I don't think that's the case for this. In the notebook space, I think it's going to be different, right? Because those specs aren't like on the box. It's not like it's not a marketing attraction for somebody to stare at necessarily.
But it might actually be sort of a RAM density memory controller combination that
as an engineer, I find myself inhibited because I would be purely speculating.
Okay, that's great,
and that's rare. That's rare for me
because I just kind of think like the question. Most laptop vendors are like, oh, I don't want to give you an extra 25 cents.
I want to text somebody.
More, so.
I want to get one of our smart architects and just ask them to answer the goddamn question. So,
it'd be interesting.
I think they're working on it.
But it does. I want to ask another question because you're talking about you got GPU now, you got CPU, you got chipset. AMD's got chipset, GPU, and it. Do you see a future 5-10 years down the line where the PC is where it is today, where it's just sort of this open, add any GPU? I just feel like the advantage to having an all AMD system or an all Intel system is going to put Team Green in a tough spot 10 years from now. But then also I understand the community, they will burn your castle to the ground if you try to move away from a 35-year-old spec. So I kind of wonder.
You're back on the ATX thing.
Well, yeah, but I mean, this is a very conservative.
It all comes here.
Nobody wants change, but to me, it feels like if I'm really going to get 15 to 20% more by combining all vendor parts, then
it's not a bad deal.
Why would I go with somebody else?
Yeah, but I would say I look at it. I agree with you. But I would also say, show me the benefits first.
Yeah.
Right. And once I see the benefits, then you can argue about openness versus the benefits. Right now, it's just if we did Intel with no additional benefits, what is that? Right.
Yeah.
So once we develop technologies that are requiring these pieces to be melded together, and there's a real benefit, then I'm all in because we can make the world a better place. But until then, we're an open, and everybody is an open platform, and I don't see a problem with that.
Yeah, no, I'm just kind of like, because I honestly, if you're going to really get more, I can see it. But then I'm just kind of afraid, like, you know what? Having a unified memory controller for all, that's looking pretty good. Why don't we do it?
Deal.
But then there's got to be some way to make that still open with,
I actually think that, so there's a lot of things to unpack here, Gordon. First, I do think we need a new chassis. Okay, so ATX, it's getting old, 35 years. The airflow in the chassis is not well
oriented. 4U rack mount. Is that the new chassis?
I love it. I love it. Passive components, fan at the bottom. Who knows, right? But at the end of the day, I agree that there's opportunity to improve PC experiences by redoing the chassis. And Intel did ATX, right? So we would be a logical person to say move that ball forward a little bit. I'd love to maybe, and I've actually talked to some of our guys about what would that look like, and it's a massive undertaking, as you know.
Right.
Yeah. So I'm all for that. Second thing is about this whole, how does NVIDIA compete in a world where there's more and more integration happening? I think they're gonna find a way. Jensen's a genius. Fish is a genius. All these guys are super smart. They work super hard, and they're gonna find a way to be competitive. So I don't worry about like these closed environments. I think it's going to be continual competition that drives the industry forward.
Good answer. Because it does, right? Because you
Family Feud episode.
Richard Dawson. Well, I'm dating.
Are you Richard Dawson?
Richard Dawson.
What's the new guy? There's a new guy.
Steve Harvey.
Okay,
Steve Harvey. Yeah.
He's good. Like him. Steve. Thanks for watching.
Yeah. Oh man. Yeah. If only he was watching. So we got a really good question in from friend of the show, VC Jester, gave us. What is this? Channel points. I don't even know what this is. Yeah. Thank you so much. Does marketing have a minimum amount of Flare X technology inside that they need to have on the retail packaging?
That's an office. That's an office space reference for having many pieces of Flare to work at tchotchkes.
I see. So this is the box.
That is a final retail package.
This is a retail package.
I think there's maybe a sticker on the back or two that needs to be updated.
I think it needs more Flare.
No.
Gordon thinks it needs more Flare.
Let's just get the thing out.
Well, no, we're not. Just, I think the look and style of the card matches the look and style of the retail packaging. That's one that we can control. The ad, when our partners come on, it's like it'll be their show for all that. I don't know if it was a serious question or not. There is like some minimum of like you've got to have an Intel Arc logo on there at some point.
Do we have brand guidelines for all the partners? I think
we do. Yeah,
of course we do. Of course.
But I just kind of think like, honestly, seeing how actual retail customers buy, they see PCI 4.0, they see 12 gigs of RAM, they have this much memory bandwidth. They're like,
does this even say 16? It doesn't
AV1 encode. I don't know what that is. I'm going to buy it because it does AV1 encode, right?
Wow, this is a minimalist box.
It feels like it needs a little more flair.
I think when we get to I think there might be additional stickers that go
on. Oh, right. I see. Okay.
But yeah,
I dig it.
Who buys retail anyway?
Yeah, that's true. I don't know. I love Best Buy. Best Buy's great.
We got another hard one from Dr. Ian Cutress.
Jesus Christ.
Yeah, 42. Is Intel really new? Isn't the messaging that Intel sells more GPUs than anyone else and has been selling GPUs for 20 plus years? What the marketing has been since then? I'm getting frustrated with the "we're new" message.
I think so. Okay, Ian. I think you know the answer to this. I think Ian knows the answer to this question. Right? And he knows that selling integrated graphics or talking about having an install base of integrated graphics is very different than the process of selling discrete graphics, building and selling a discrete graphics product.
And not just that, the driver's all different.
Yeah,
the
technologically as well as business.
And the business is all different, which is the biggest part of this that I didn't appreciate this just, even a year ago, how different the business is. And that's a major entrant kind of issue. And not just that, like, how do we convince our community of gamers that you can trust us, right? And that's a major new entrant.
Yeah, and I would also agree, and frankly, would you really consider Intel UHD graphics? Like, it's sort of like I know
and shade again.
But that I mean, it's been the butt of everybody's jokes until Iris came along. Really, honestly, I mean, it's been like.
Do you know what our performance trend for integrated has been? Are you aware of the performance trend for integrated? Let me tell you.
Years,
yes,
it's like this.
It's like a rocket ship. It's up and to the right, Gordon.
But let's talk about all the years of like all the pieces on the ground scattered everywhere.
Yes,
and to me, I think Intel could firmly say it's new because it
is.
Because I mean, the record of the previous 20 years in graphics was,
I thought it was an excellent.
Really
it was just a different focus.
Focus.
Yeah.
Yes.
It's not a bad record. It's just a different record. It was media focused.
Yeah.
And if you look at QuickSync and all of the decoders and all the hardware accelerators.
Efficiency. Just think about power efficiency
They did amazing stuff. And I still remember the day. I forgot what it was. It's like QuickSync showed up on, do you know where was it Sandy Bridge? Where QuickSync showed up? And I was like,
sounds right.
Holy cow, that thing is really, really fast doing these complex encoding. And I was like, wow, NVIDIA just got their ass kicked by integrated graphics, right?
Right, and then of course, came back
own
thing, but I mean,
came back.
It really, you're right. It didn't focus on graphics performance, but that,
it didn't focus on gaming performance.
Display, number one display technologies in the world, right? If you look at the long-term trend of integrated graphics, display was always at the top.
Okay, yeah. I guess it's like for me, I always remember the dark days of like when it felt like people said PC gaming was dead, and honestly, I honestly blame Intel.
Wow.
I blame Intel integrated. Well, and it was fine because it did great. But if you think about 810, Whitney was like, it turns your screen on. That's basically your bar for, and it was awesome because you didn't have to buy a separate ATI, part to put on the board.
Yeah.
But it was just like, it didn't really sort of strive for more. And, honestly, it probably didn't affect Europe and Asia as much because they always bought integrated graphics.
Right.
But the messaging I've always heard in the U.S. is like, people don't buy just graphics cards. They just buy the computer.
Yep.
And then they were stuck with, oh my God, I can't run this game and it was gaming. The concentration was for consumers.
I feel like Intel's really come quite a long way in just a short period of time. When you look at Gen 11, Gen 12, Tiger Lake, and then
even 10th Gen,
Ice Lake
was like
Ice Lake, Tiger Lake, and it's just been a 2x, and now with DG1 and DG2, and even up our stack, I think our graphics performance. If you looked, is it 8x? I think it's more.
Oh, I was talking about just since
Tiger Lake
9th gen.
Yeah. So I would say amazingly fast perf growth, and what that's done is exposed opportunities for driver improvement. Yeah,
but I think it's new. I think you can firmly claim you're new. So I disagree.
Yeah, definitely new.
Definitely new.
Even though Ian's way smarter than me, I disagree.
Is Ian is in England, right?
Yes.
Okay.
Right. I mean, I don't know where he is today.
Well, is he awake?
He's a jet setter.
Is this a bot? Is this a bot?
Oh, that would be funny. I don't know how Twitch works. So, we do have another good question over here on Discord from friend of the show Starscream. Well, actually, two questions. One of them you kind of answered. So, are there any plans for Arc to have SLI / Crossfire type support?
It's an excellent question. You know, my answer right now is not right now, because we have plenty to do on discrete GPU, and we don't. And anybody who knows about SLI and Crossfire knows about the bubbles and the wrinkles and the warts on that technology. I don't think I would replicate that technology. Like the idea of they use a technology called AFR, where they kind of render one frame on one graphics card, and they render the next frame on the next graphics card, and then they try to bring them together onto that one graphics card, and they scan it out. That doesn't work very well with modern engines and modern titles, and I think it's kind of shown to be a real difficult technology to carry forward. If I were going to do multi-GPU, it would be much more fine-grained. So think of it as, if we can find a technology that can distribute work across threads, across GPUs, that's the way to do it. Sort of transparent to software. But we don't have that magic ring yet. We don't. Yes, sir.
I'll say DaVinci Resolves has really good multi-GPU support.
Yeah, and if we could do render that way.
And that's application level.
Yeah, and it's an application level awareness. So so there's like this holy grail is, can we make multiple GPUs transparent to the software in some way? Or can we make a layer in software that is ubiquitous so that multi-GPU just works? And it's not some kind of hacky thing. So right now we're not there, but if someday we were there, that'd be fantastic. And I think what's going to drive some of that is that there's these new architectures that are coming 3, 4 years, or 5. I'm not going to talk about mine, but I've heard about other people that are developing multi-tiled GPUs. And a multi-tiled GPU is exactly that. You're kind of saying there are multiple different compute units that are all rendering on the same frame in parallel, but they're different chips. Now, how are they going to make that work? Well, it's either going to have very big caches that are close, and they literally have roughly the same performance, even though they're different chips, or they're going to need some kind of layer that does parallelism on top of the cores. It's very cool tech, just not there today yet.
Even if you guys supported SLI, I would not recommend anybody use SLI or Crossfire or whatever you want to call it these days, because the experience is terrible.
Yeah,
in today's environment.
Yeah, I hear you, Brian.
A couple more questions, and then we can get out of here. One of them, I'll go back to Dr. Ian. He's got 2 questions left, and I'm cutting him off.
All right.
So,
you're out of here.
Yeah. You're out of here, Ian.
Will everything about Arc be in the public before Intel Innovation? What will be shown at Intel Innovation?
I think the answer is yes, but I don't know. I think the answer is yes. Our intention, and this again, it's a different strategy than what most people use for launch. We talked about it earlier. We're, meaning Ryan and I, are disclosing all the cool bits of the technology of Arc directly. So that means we're doing blogs, we're doing videos, we're reaching out to press, and it's a much more intimate discussion because we want to make sure people get a chance to ask questions, and we're not bringing everybody together for a giant press event and then having some kind of launch moment later. So I think everything important about Arc, we hope to go direct to our gamer customers and our partners.
Yeah. And by the way, just for Intel Innovation is the conference we have at the end of September in San Jose. That's like our technology-focused Intel event. It's just people don't know what innovation is. I would say by this time, yes, everything is disclosed, and
we're on our way.
We're on the way.
Yeah.
So we did kind of get a timeline from you guys.
Hey, now, I didn't say that. Ryan Schratt said that.
You did say it first.
I did. Okay. Did I? I think I said maybe. I don't know. Can I soften that up? Everything that we just said, maybe.
Asterisk. Another business question from a friend of the show, Cause MC. Do we think there is honestly enough chip manufacturing potential in the U.S. to warrant a $50 billion government investment?
Ooh, that is a bit off topic, but I will give you my sense of it. First of all, I'm not party to anything related to that particular act or deal, and I'm not a politician, and I don't have any contact directly with politicians. However, I do have great confidence confidence in Pat, who I think has done a great job coming back and like looking at our what has traditionally been a giant strength of Intel, which is our technology and our manufacturing. And when Pat returned, he's like, "What have you guys been doing? Hello." And so, right away he started in on, let's make our technology the best in the world. Let's do the investments, the massive investments that are needed to move our foundries forward and create a whole new foundry business. So I have a lot of confidence in that strategy. And, it's great to be part of Intel while this transformation is happening. So I know that sounds a little bit like a party line, but it is actually true.
Well, and I can answer it on my own opinion, because I just think that, yeah, they're clearly, if you haven't been paying attention to current events, the chip technology happens to be a strategic goal of the United States, and it would be valuable to have it contained within our borders and, easily not available to the entire,
I'd like to be able to buy a car more readily.
I'd like to be able to.
Yeah.
My car is 20 years old. No planned upgrade.
I just bought a car. My story, though, is I ordered a 2022 model at the end of 2021.
Yeah.
And I received it when the 2023 model came out.
Oh.
That's how long it took.
Wow.
So.
You don't want to tell your story.
I don't.
I know you don't.
I don't.
Offline.
I definitely want to hear that.
Okay. Uncle Elias, friend of the show, has a question. Does SteamOS work with Arc?
Huh.
Or along those lines, is there Linux support?
Linux. We love Linux. So I don't think Linus is ever going to give us the finger. So I would say
Torvald.
Torvald. Yeah.
And Sebastian might.
Sebastian might.
Yeah.
No, definitely
double
he will.
fingers.
He will.
Fingers,
Eventually he will, and he knows I love him. So, but at the end of the day, the Linux thing is very obvious. We're open source. We already have an open source driver. We are all in on open standards, and Linux is just part of that. So you can see our driver. Now it is going to be interesting as we go forward, and Linux is now spreading into multiple adjacencies like SteamOS, and gaming on Linux becomes more and more of a thing. My suspicion is that we have work to do on the gaming performance as you get broader, demand for Linux gaming. But right now it's in pretty good shape. I expect we're going to continue to invest there.
How do you deal with the closed IP issues with a driver? Because definitely,
it's really hard. I don't know the technical details of how we're doing it. I will. I don't right now. Do you know? Like, how do we hide like the shader compiler? And all that kind of stuff? Yeah. So that's a great question, and unfortunately I don't know the answer.
Okay, because I was just thinking, even for third party, like if there's some codec that you're paying royalties for, you can't simply give it up to the world.
Sometimes there are chunks that are not open in these open source drivers. There's like compiled bits that just stay obfuscated, but I don't know that to be the case. In this case.
Yeah, because I was talking to a third party encoder company, and it's like, how come VLC can do it for free, but you gotta pay.
Yeah.
The cool thing, their answer was like, well, we have money to sue us, so they can sue us. VLC is like,
is it like three guys in like a
Well,
or is that a distributed community?
More distributed.
I think it's distributed, and basically there's basically you don't sue.
Who are you gonna sue?
Who are you gonna sue? So
Can't cut off
it's
the
like
head.
crypto,
and it's just because they have there's no how lawyers are. They want money they want to squeeze the company for money, and you don't squeeze.
So you're saying if we did a VLC, we would get sued?
Yes,
100%.
I understand it, because I get it, because there's always a lawyer waiting for someone, and I love lawyers. You need a good lawyer, like you need a good doctor.
We have great lawyers.
But yes,
I love our lawyers.
They can be annoying sometimes. You know what I'm talking about, lawyers.
All right, two last questions and we'll get out of here. Sorry, there's a really good one from Vipdis again. Are board partners allowed to go off spec, like more VRAM, more power, multiple GPUs on one card, etc.?
So board partners, it's not really allowed. Like, board partners are enabled to do different things, and they're in charge of their own destinies. I would say that we give them a reference design, which has a tremendous amount of engineering effort to do, and we also control the driver. So our driver doesn't support multiple GPUs on the same card. So I doubt that anybody would do that, and we wouldn't do the work to enable that. Right. But that's a different mindset, right? We don't allow our board partners to do anything. They are allowed to do whatever they want. Certain things will work and certain things won't work, and we have advice for them. In the case of the 770, there is an 8 gig SKU. There's also a 16 gig availability to do that SKU, but we don't think people should build that SKU in general. We think they should do the 8 gig SKU because it's got a much better per dollar benefit, but AIC is going to do what AIC is going to do. Yeah. And that's just the way life is, and we love that. That's called differentiation and decentralized decision making, and it works. It works. It's called capitalism.
They know their customer.
They know their customer.
They know how many RGBs they need to put on their card.
And I love that.
How many fans? Yeah. All right. Last question from Dr. Ian Cutress. I guess might as well. Yeah, might as well have his last one. It's pertinent to him. Question: how does the chip taste? And I'll follow up. How does that GPU taste? Does either of you tried to lick it?
No, I have not licked it. I have not licked it. Let me just give it a quick sniff. That smells like bacon.
Smells like bacon.
It doesn't smell like bacon.
That does not actually smell like.
It doesn't smell like bacon.
Would that be a pro or a con?
Oh, that would be pretty good.
You know the Baconator?
You warm it up in the case a little bit. You start to get that smell.
That could be the new smell-o-vision, right? Like you just go like, because everybody loves the smell of bacon. Even vegans, they love the smell of bacon.
So the driver name used to be for, I'm thinking like XF. What was it? Terminator? Was it Terminator? Detonator.
Oh, yeah, right. For the NVIDIA.
Oh, my God.
Yeah.
Yes, that was a while ago.
Back in the day. 3DFX, right?
Was theirs Detonator?
I don't know. Was it ATI?
No, Detonator.
No.
God, because now you're
going to have to know. Somebody in the chat.
Detonator was an NVIDIA.
Yeah.
Okay. But now I don't know if they adopted it from 3DFX or not. But I doubt it.
If you actually look back, but if you think about it, like as a product name, that's like not really good. Right?
It's just going to blow up.
Detonator. I mean, honestly, there was an entire board maker. People don't remember TNT. Well, I mean, that was you had TNT. I guess that kind of goes to the TNT thing.
Well, that was the whole 3DFX thing, right?
No, I think that was TNT related then.
Oh, so it is the NVIDIA Detonator driver, yeah.
Yeah. That was like, I mean, that's old school.
That shows you how ignorant I am, because I really didn't know that.
You know what it is there's just gaps that, like, there's things that kind of fade out of memory.
Did you see us talking with Linus like the other night? We're sitting on his late night show, just chit chatting. It's just like a trip down memory lane. Just so much history. We could do the same thing someday.
I love that. You know, like I got those old cases, and like I went to this dude.
I would love that.
30 years of machines. And and it really is interesting because I really. I've said this. I don't want to get too far because I know people like go to the bathroom, but like, I really think like people, and I'm saying this like definitely I'm in my get off my lawn phase.
Yeah.
But my kids have no idea. They just simply think the world appeared with RGB and awesome performance and good airflow, and like it's just like that. And it was just like you go buy it for cheap using some build thing and it's ready. But no, it wasn't like that. It was like a fight. Every day was a fight to get here.
Uphill,
this is just like when
both ways.
People have been trying to kill the PC for 20, 30 years. And I kind of think like it's not here except for key people in the industry that have fought for the PC, right? Really, because it took a lot of fight, and then now people just think they take it for granted.
Right? Before we started recording, we were talking about the good old days of print magazine coverage as well, right? So I feel like we may be past the off my lawn age.
We're like a banana that's like not quite rotten.
Yeah. We're in the old folks home, like just complaining.
It's a little brown.
The person that brings you your meal is like, wait, let me tell you about the Detonator drivers. Like,
I don't know how long we've been talking, but I know that one quote that I just gave, that's the one that I'm going to hear about tomorrow. That's the kind of world we live in.
Yeah.
You probably have a patent on it.
Oh boy.
All right, Gordon,
should I take us out?
Let's get us out of here.
I'm going to take us out. Check back next week for your fix of PC Talk on the Full Nerd for audio listeners. Subscribe to us on iTunes, Google Play, Spotify, or Stitcher. And if you're on one of the services, please do leave a review. Every time you do, Dr. Ian Cutress will ask a question somewhere in the world. Also send questions and comments to thefullnerd@pcworld.com if they haven't turned it off by accident. Thanks for coming. I'm Gordon Ung with Brad Chargas.
Adios, y'all.
Tom Peterson.
Adios, y'all.
Ryan Shrout.
Thanks for having us.
And Adam Patrick Murray's going to hit the L switch.
Hey, thanks everybody live joining us on Twitch. Hopefully we'll have YouTube back soon. We will talk to you later. And thanks, Ryan and Tom, for
Absolutely.
coming on.
Thanks for hosting.
See you again.
It's awesome.
We'll do it another time.
Yeah.
Thanks, everybody.
Bye, Brad.
Bye.